Hi friends, today we will study Class 10 Science Chapter 12 Electricity Part 1, in which we shall cover electric current, potential difference, resistance and Ohm's law. We will also do an experiment on series and parallel resistors. PDF of all the notes is available in the description box. So let's understand the basics first. So charge is basically the flow of electrons and its unit is coulomb or C. Now the rate of flow of this electric charge is known as electric current. That means that the amount of charge passing through a particular area in a unit time, that is known as electric current, or I, that is current, is equal to Q, that is charge, divided by T, that is time. Unit of current is ampere and it is measured by ammeter. So if we say that a charge of 1 coulomb passes through a unit area of cross section in 1 second, then a current of 1 ampere will be produced. Direction of electric current. This is from the positive terminal to the negative terminal. That is opposite to the direction of electrons, and they move from the negative terminal to the positive terminal. How does current move in a circuit? For this, we will consider a real life example. Let us take current to be water, and we will take two tanks that are full of water and they are connected with a tube in between. So if we take two tanks that are at the same height and then try to move the water from one to another, it will not move or flow. But if we place one tank at a higher level than the other, then a difference in heights is created and the water flows from the higher tank to the lower tank. Similarly, for current to flow in a circuit, we need to create a difference in electric pressures, and this is called potential difference. Now let us discuss this potential difference in detail. Its symbol is V and its unit is volt, which is named after the scientist Alessandro Volta. Now, how is this potential difference created in a circuit? It is created by a battery, and battery achieves this by utilizing its chemical energy which is stored in it. So let's define potential difference in the form of words. I have already explained it to you in the earlier section. It is the work done to move a unit charge from one point to another point. Or V, that is potential difference, is equal to W, that is work, divided by charge, that is Q. So if we take 2 points A and B and we take a unit charge of 1 coulomb, and the work done to move that charge of 1 coulomb is 1 joule, then the potential difference between the points A and B will be 1 volt. Now let us do a numerical on potential difference. So the question here is that 3 2-volt cells are connected to make a battery. So first part is, what is the potential difference at the terminals of the battery? And second part is, how many joules of electric energy is gained by 1 coulomb of charge passing through the battery? So answer, first part. So as we know that total potential difference is equal to sum of potential difference of all the cells, which are 3 in this question. So it will be, as one potential difference of one cell is 2 volts, so for 3 cells it will be 2 plus 2 plus 2, that is 6 volts. B part. We know from the earlier formula that electric potential is equal to work divided by charge. So we get the formula that work is equal to potential difference multiplied by charge. Or we know that energy is equal to work, so we can write this formula as energy is equal to potential difference multiplied by charge. So potential difference is 6 and energy is, and charge is 1. So we get energy as 6 into 1, that is 6 joules. Now we will understand the Ohm's law. It was given by George Simeon Ohm. So what he did was that he made a circuit by using a single cell, and he recorded the current in the circuit by using an ammeter. Then he added another cell into the circuit and he observed that the ammeter reading had increased. When he added another cell to the circuit and made it, so he used a battery of 3 cells, then he observed that the current had furtherly increased. So this means that when we increase the voltage, that is the potential difference, then the current in the circuit also increases, or V is directly proportional to I. This is nothing but the Ohm's law. Now if we remove the proportionality sign from this equation and instead put an equality sign in between, then a constant, that is R, comes into the equation. So the equation becomes V is equal to IR, and this R is resistance, about which we will study in the next session. So resistance is the property of a conductor to resist the flow of charges passing through it, and as its name suggests, its unit is ohm, represented by the Greek letter as you can see in the notes, and its symbol is R. Now in the Ohm's law, that is V is equal to IR, if we take I to the other side of the equation, then it becomes R is equal to V upon I. That is, resistance is equal to voltage divided by current. So if we take a circuit in which there is a battery of voltage 1V and the current of 1 ampere is flowing through it, then resistance of 1 ohm will be produced in the circuit. Now let us solve a numerical based on Ohm's law. So the question here says that the potential difference between the terminals of an electric heater is 60 volts when it draws a current of 4 ampere from the source. So it asks that what current will the heater draw if the potential difference is increased to 120 volt. So here basically heater can be considered as a resistor, and in the first question he is telling us that the potential difference, that is V, is 60 volts. The current I is 4 amperes, and from the Ohm's law we know that V is equal to IR. So from here, by transposing I to the other side, we can get that R is equal to V divided by I. So when we put the values of V and I into the equation, we get that R is equal to 60 divided by 4, that is 15 ohms. So now the new potential difference, let us take it to be V dash, is 120 volts as it is given in the question. But the resistance remains the same, as resistance doesn't change unless temperature changes or length or area of cross section changes, which hasn't in this question. So now let us apply the Ohm's law again. V is equal to IR. So I dash is equal to V dash upon R. So I dash is equal to 120 divided by 15, that is 8 amperes. Hope you have understood this question. Factors affecting resistance. For this, we will take a metal conductor of length L and area of cross section A. Now if we increase the length of this conductor, then the resistance of this conductor will also increase, or resistance is directly proportional to length. And similarly, if we increase the area of the conductor, then also the resistance will decrease. This means that resistance is inversely proportional to area, or resistance is proportional to 1 upon area. So combining both these statements, we get that resistance is directly proportional to length divided by area. And if we remove the sign of proportionality and place a constant, then we get the statement that R is equal to constant length upon area. And this constant here is resistivity, represented by the Greek letter rho. Now what is this resistivity? This is basically a constant, and every material has its own resistivity. Now metals like aluminium, silver, copper, etc., they have low resistivity, so they are very good conductors and they allow the electricity to pass through them easily. While the insulators like glass, plastic, rubber, etc., they have very high resistivity, so they do not allow the electricity to pass through them easily. Combination of resistors. Now, resistors can be arranged in two combinations. They are series and parallel combination. Series combination. So for this, let us make a circuit having a battery of voltage or potential difference V and current of I passing through the circuit, and it has two resistors of resistance R1 and R2, potential difference V1 and V2, and current I1 and I2. So now in series combination, each resistor has same current and that is equal to the current of the circuit. So that means that total current of the circuit, that is I, is equal to the current of individual resistors I1 and I2, or I is equal to I1 is equal to I2. Also, in a series circuit, the total potential difference, that is V of the battery, will be equal to the sum of the potential difference of individual resistors. That is, V is equal to V1 plus V2. Now, if we apply Ohm's law to V, V1 and V2, we get that V is equal to IR, V1 is equal to I1 R1, and V2 is equal to I2 R2. Now we put this in equation 1. We get that IR is equal to I1 R1 plus I2 R2. Now as we know that I is equal to I1 is equal to I2, so we can take them common and cut them. So from this we get the final equation R is equal to R1 plus R2. This means that the total resistance in a series combination is equal to the individual resistances of the resistors. From this we can conclude that the total resistance in a series combination is greater than the resistance of any individual resistor. Now let us solve a numerical based on series combination. So the question here says that an electric lamp whose resistance is 20 ohms and a conductor of 4 ohm resistance are connected to a 6 volt battery. Calculate part A, the total resistance of the circuit, part B, current to the circuit, and part C, potential difference across the electric lamp and conductor. So let's start the solution. First part. So we know that in a series combination, total resistance is equal to R1 plus R2. That is 20 plus 4 is equal to 24 ohms. Part B. In this we have to find the current through the circuit. By Ohm's law we know that V is equal to IR. So by transposition we can get I is equal to V upon R. And by putting the values of V and R, we get that I is equal to 6 upon 24, that is 0.25 amperes. Part C. So in this we have to find a potential difference across R1 and R2, not across the entire circuit. So for this we will consider the current and resistance in R1 and R2. Let's start with R1 first. So for R1 the potential difference will be equal to I1 R1, but as we know that I and I1 are equal, so we can write it as IR1, that is it is equal to 0.25 amperes into 4, so potential difference becomes 1 volt. Similarly we will find for R2. For R2 potential difference will be IR2, and by putting the values we will get the answer as 5 volts. Now let us understand parallel circuits. So again we have connected a battery of V volts and a current of I amperes is passing through it, but this time we are arranging the resistors in a parallel combination. So the first resistor has a resistance of R1 and the second resistor has a resistance of R2. Now when the current reaches a junction P, it divides into I1 and I2. So the total current is equal to I1 plus I2. Now each resistor has the same potential difference. That means that, and that is equal to the total potential difference of the battery. That means that V is equal to V1 is equal to V2. Now putting Ohm's law, we get that I1 is equal to V1 upon R1, I2 is equal to V2 upon R2 and I is equal to V upon R. Now from equation 2, we put the values of I1 and I2 in this equation and we get that V upon R is equal to V1 upon R plus V2 upon R. Now as V1 and V2 are equal to each other, so we will take them common and then they will cut out. So final equation we will get at 1 upon R is equal to 1 upon R1 plus 1 upon R2. This means that the total 1 upon total resistance is equal to 1 upon resistance 1 plus 1 upon resistance 2 and so on. From here we can conclude that in parallel combination the total resistance is greater than the resistance of any individual resistor. So let us consider two resistors, first of resistance 10 ohms and second of resistance 20 ohms. So if we arrange them in parallel combination, then total resistance will be lesser than the least resistance. That means it will be lesser than the 10 ohm resistance. But in series combination, it will be greater than the 20 ohm resistance. So from here you can understand it better. Now we will understand series and parallel resistors with the help of two live experiments. Let us see the setup for this experiment. In this, I have taken a battery of 2 cells and I have connected it to a buzzer, and I have taken two resistors of resistance 20 ohms and 10 ohms that I have arranged in series combination, as you can see here. So now if I will first show you how the voice comes when I don't connect any resistor. As you can see that the voice is very loud. Now I will show you the voice when it comes, how the voice comes when I connect it through a series combination. You can notice that the voice is lesser loud than before. Now I have arranged it in parallel combination and you can see that the voice is more loud than it was in series combination. So this means, this proves our equation that in series combination the total resistance is greater than individual resistance, and in parallel combination the total resistance is lesser than individual resistances. So as the total resistance is lesser in parallel combination, we hear a more loud sound. Now let us solve a numerical on parallel circuits. So the question here is that in the figure 5 resistances R1, R2, R3, R4 and R5 and a 12 volt battery is connected in an arrangement. Calculate the total resistance in the circuit. So here basically we have to find the current and the resistance. So for easy understanding, I have made two parallel circuits in this question, P1 and P2. So in P1, we know that in a parallel combination the total 1 upon total resistance is equal to 1 upon R1 plus 1 upon R2. So by putting the values of R1 and R2, we will get that 1 upon R is equal to 1 upon 10 plus 1 upon 40. Now solving the equation, we will get R as 8 ohms. Similarly, we will do for P2. We will get that 1 upon R is equal to 1 upon R3 plus 1 upon R4 plus 1 upon R5. By putting the values, we will get the resistance in P2 circuit as R is equal to 10 ohms. Now we get a series combination consisting of a 8 ohm resistance and a 10 ohm resistance. So total resistance will be 8 plus 10, that is 18 ohms. Now let us discuss the advantages of parallel circuits over the series circuits. Point 1. In parallel circuits, if one component stops working, then all the other components keep working normally. But in series circuit, if one of the component fails, then the entire circuit gets broken and none of the component works. Second, In parallel circuit, the total resistance gets reduced, as I told you earlier. Third, in parallel circuit, it is very helpful when each gadget has different resistance and requires a different current to operate properly. This is not so in series circuit, where the same current flows through all the devices irrespective of their resistances. Series circuit is not useful for appliances that need currents of widely different values. For example, if we make a series circuit with an electric bulb and an electric heater, then it would not work properly, as electric bulb requires very little amount of current, while an electric heater requires a lot more current. So in such a case, a parallel circuit should be used. We can also understand the advantages and disadvantages of series and parallel circuits with the help of this same experiment. So here I have connected the two resistors in parallel combination and I am passing the current. But now let us consider that my second resistor of 20 ohms malfunctions. So I am removing this 20 ohm wire. But still, even when I have disconnected this resistor, still this 10 ohm resistor is functioning properly and the noise can be heard. Now I have arranged in series combination and I am completing the circuit. Now you can hear that the voice can be heard, but let us consider that this 20 ohm resistor has again malfunctioned. So I am removing this wire. But now as you can see that the entire circuit has been broken and no sound can be heard. So this proves that in series combination, if one device malfunctions, then all the circuit gets broken.